cubaan kamera tak on kan. 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 Cubaan. Kamera tak on kan? 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 Cubaan. Kamera tak on kan?
Hả? Control?
Cubaan.
Tak tu kat sana.
Kamera tak on kan?
A punya. B masuk prioritization video.
Siapa yang kontrol?
Aku control lah. Ha? Oh, yang tu kan. Yang lagu dua. Control.
Cubaan.
A yang masukkan lagu ni. Tak tu kat sana.
Kamera tak on kan?
Kita tak masuk lagu. A punya. B masuk prioritization video.
Siapa yang kontrol?
Kat nak test. Ha? Oh, yang tu kan. Yang lagu dua. Control.
Cubaan.
A yang masukkan lagu ni. Tak tu kat sana.
Kamera tak on kan?
Kita tak masuk lagu. A punya. B masuk prioritization video.
Siapa yang kontrol?
Kat nak test. Ha? Salah. Oh, yang tu kan. Yang lagu dua. Control.
Cubaan.
A yang masukkan lagu ni. Tak tu kat sana.
Kamera tak on kan?
Kita tak masuk lagu. A punya. B masuk prioritization video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa yang telefon?
Kata test lah.
Ha?
Salah. Oh, yang tu kan. Yang lagu dua. Kau Baju yang masukkan lagu. Tak tu kat sana.
Kabel kat yang mana?
Kita masuk lagu. punya. B masuk private session video.
Siapa
Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata test. Ha? Asal. Oh, yang tu yang lagu apa tu? Cubaan. A yang masukkan lagu. Tak tu kat sana. Kita masuk lagu. A punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata salah. Oh yang lagu apa tu? Baan juga yang masuk lagu. Tak juga kan? Kita masuk lagu. punya. B masuk private session video. Kata
exactly, and you have understood the meaning of this lines. How does the interactive results in or shut that coming back to the session. Before we begin, I would like to remind you exactly, and you have understood the meaning of this lines. How does the interactive results or shut that coming back to the session. Before we begin, I would like to remind you exactly, and you have understood the meaning of this lines. How does the interactive results or shut that coming back to the session. Before we begin, I would like to remind you exactly, and you have understood the meaning of this lines. How does the interactive results or shut that coming back to the session. Before we begin, I would like to remind you exactly, and you have understood the meaning of this lines. How does the interactive results or shut that coming back to the session. Before we begin, I would like to remind you exactly, and you have understood the meaning of this lines. How does the interactive results or shut that coming back to the session. Before we begin, I would like to remind you exactly, and you have understood the meaning of this lines. How does the interactive results or shut that coming back to the session. Before we begin, I would like to remind you exactly, and you have understood the meaning of this lines. How does the interactive results welcome back without further Mazid Ahmad Rajab, Nur Izi Arbai, Widyati Yofi, Sri R. Widyawati, Izati Rahmi, Mazid Ahmad Rajab, Nur Izi Arbai, Widyati Yofi, Sri R. Widyawati, Izati Rahmi, Mazid Ahmad Rajab, Nur Izi Arbai. Mr. Rizwan, you can start your presentation. Widyati Yofi, Sri R.
Okay, thank you so much
Izati Rahmi,
to our chairman. But I already sent the video, right? So you can on my video presentation first.
Mazid Ahmad Rajab, Nur Izi Arbai. Mr. Rizwan, you can start your presentation. Widyati Yofi, Sri R.
Okay, thank you so much
Izati Rahmi,
to our chairman. But I already sent the video, right? So you can on my video presentation first.
Mazid Ahmad Rajab, Nur Izi Arbai. Could you please wait for a moment? Start your presentation. Widyati Yofi, Sri R.
Okay, thank you so much
Izati Rahmi,
to our chairman. But I already sent the video, right? So you can on my video presentation first.
Mazid Ahmad Rajab, Nur Izi Arbai. Could you please wait for a moment? Start your presentation. Widyati Yofi, Sri R.
Okay, thank you so much
Izati Rahmi,
to our chairman. But I already sent the video, right? So you can on my video presentation first.
Mazid Ahmad Rajab, Nur Izi Arbai. Could you please wait for a moment? Start your presentation. Widyati Yofi, Sri I'm sorry, Mr. Rizwan. I see it looks like you have some confusion here. The video is for the backup only if we have some connection issues, but you still have to present virtually in this session.
Okay,
I'm sorry,
I need
Mr.
to check
Rizwan.
my file first.
I see.
Okay, sure, sure.
It looks like
Okay,
you
thank
have
you.
some confusion here. The video is for the backup only if we have some connection issues, but you still have to present virtually in this session.
Okay,
I'm sorry,
I need
Mr.
to check
Rizwan.
my file first.
I see.
Okay, sure, sure.
It looks like
Okay,
you
thank
have
you.
some confusion here. The video is for the backup only if we have some connection issues, but you still have to present virtually in this session.
Okay,
I'm sorry,
I need
Mr.
to check
Rizwan.
my file first.
I see.
Okay, sure, sure.
It looks like
Okay,
you
thank
have
you.
some confusion here. The video is for the backup only if we have some connection issues, but you I'm sorry, Mr. Rizwan, but we can't
Yeah,
hear.
you
We
cannot hear?
Yes, yes, we cannot hear your
Okay,
video.
okay, okay, okay. What's wrong with my? Mm, 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 mm.
Mr. Rizwan, there is one situation here. If you want to just play your video, our technical
Mhm.
team will play for you. But if you want
Yeah,
to present virtually, but you can just use your slide. So which one you want to present?
I prefer to on my video by organizer. Can
Okay,
you
sure.
please? Yeah, yeah.
Yeah, sure. Thank you.
Assalamualaikum and good afternoon to all of you. Now I'm going to introduce my paper with title Improve Rough Multiple Regression for Unemployment Rate Model in Indonesia. I am Rizwan Effendi and here also some co-authors, namely Mazidah Madrajab, Nur Ezi Arbe, Vidya Tamakayofi, Sri Rahayu Widewati, Izzati Rahmi and also Hazmira Yoza. The outline presentation first about introduction, problem statement, fundamental concept, result and discussion, and also conclusion. Okay, I believe that most of you still remember with the COVID-19 pandemic and so many problem issues that occurred on that time. For example, increasing of unemployment rate in any country or region in the world. Here, we concern about Indonesian country. We can see from the table or from the graph, we can see that 2019, the percentage of unemployment rate about 5.02%. But during COVID-19 2020 or 2020, we can see that the percentage increase around 1.84%. So here we want to check what is the contributed factors that are related to unemployment rate. So and after that we can try to make a model based on statistical approach. Okay, in this slide I will talk about problem statement. Based on our references or literature review, we conclude that many researchers implemented the regression model to investigate the unemployment rate and its factors. However, the researcher or the previous work does not concern with the uh, inconsistent information in the data set. So, in this paper, we are interested to implement the data reduction of rough set to uh, ordinary regression, especially dummy regression model, in improving the performance of accuracy model. Okay, in this slide, I will talk about fundamental concept, especially about similarity and difference between uh, regression and also rough set. First, we talk about similarity. First component, data analysis. Both approach, regression and rough, are used to analyze data and extract meaningful patterns or relationships. They can handle both quantitative and also qualitative data. Another thing is about attribute selection. Yes, both approach can be implemented to investigate or to select the significant attribute or factors. And the last component is about handling uncertainties. Both approaches can manage the uncertainties in the data. Rough set theory explicitly deals with indiscernibility and approximation, while regression can be accommodate variability in the data through statistical method. Okay, now we are going to talk about difference both approaches. Rough set theory focusing on how to classify data into lower and upper approximation, while ordinary regression focus on a relationship between dependent and independent variable. Now we are going to talk about dummy regression model. Dummy regression model a little bit different with simple linear regression or multiple linear regression, because in this model we have a dummy variable. Dummy variable can be categorical type, and another thing looks like similar with a simple or a multiple linear regression. What is a dummy variable? Dummy variable are created to represent categorical variable, enabling the use of regression analysis for the data set that include non-numeric categories. For instance, if we want to analyze the effect of education level on income, so we might create a dummy variable that indicate whether an individual has a postgraduate degree, 1 or 0. So this allows us to quantify the impact of having a higher degree on income while controlling for other variables such as years of work experience. Okay, now we are going to talk about data reduction of rough set. This data reduction is very useful to reduce or to remove the inconsistent information in the data set. So that's why this idea we try to integrate with the dummy regression model and improve that model into higher performance or the better performance if we compare without any data reduction approach. In this slide, I'm going to talk about methodology, sample, population, and also variable. So the population in this research is all regencies or cities in Indonesia with a total of 514 consisting of 418 regencies and 98 cities. And the variable of research first is about labor force, gross regional domestic product, human development index, total population, province as a dummy variable start from D1 until D34, and also dummy district and cities. Okay, in this slide, I'm going to talk about the result and discussion. So here we can see that the better improvement that can achieve if we implement the Ralph set theory into a dummy regression model. So we can see from the related variable, R square, and also mean error. So Ralph multiple regression is better approach if we compare with ordinary multiple regression. So what is the key point here? Because we implement the data reduction that can remove the inconsistent information in the data set. In the conclusion, I'm going to say that the rule or the contribution of data reduction is very crucial into dummy regression model. We can see from both of years 2019 and also 2020 the improvement is very significant if we compare with the ordinary dummy regression only. So what is the main point here? We need to check the quality data before we are going to further analysis. So that's why here we try to integrate data reduction or data elimination of rough set into existing statistical analysis, especially dummy regression model. So furthermore, we can implement to any data set related with regression. So especially for the survey research, the data reduction is very important to be considered for researcher or any furthermore study. So thank you for your attention. And if you have any questions, so feel free to ask me. Again, thank you so much. Back to our moderator.
Thank you to Mr. Rizwan Effendi for his insightful presentation. Next, may I ask first for the next paper, who would be presenting? Mr. Rizwan, do you know, because you are one of the author? I saw Mr. Abdullah is here
Yeah,
just now.
yeah.
Uh, Excuse me, Mrs. Shabila, Mrs. Nur.
Yes.
In the schedule, I'm in the fifth to present in this
Authors.
session.
Yes.
So I
You shall wait until your turn.
Uh,
The second one is paper ID 044, Abdullahi O. Adleki. Is he available? I saw him just now, but he's not available.
already left, I think.
Yes, he already left.
I think this is Dr. Azza's student, I think so. I don't know exactly.
We wait until 2:20 p.m.
Or maybe continue for the next presenter.
Uh, we have 2 minutes until 2:20 p.m. So we shall wait for Mr. Abdullahi to enter our session. To all the participants, just a warm reminder, the video that you have submitted is for the backup purposes only. You still have to present virtually using your slide, not using your video during the session. Thank you. So our next session will start with paper ID 044, but I don't see any presenter for this paper. Is anyone here? For the paper 044, improved classifier chain method based on particle swarm optimization and genetic algorithm for multi-level classification problem. Unfortunately, we do not have your video for backup, so you need to present virtually. No. So I think we shall proceed to the third paper, ID 062. May I ask whether the authors is here yet? Muhammad Akmaluddin Ahmad Ramli and Roslina Mohammed. Are you available now? Madam Izati Rahmi, are you available to present now? As yes, she's here. Can you present now? Is it okay for you?
Okay, Miss Nur. It's
Let me introduce you first. So next, we are going to proceed with our this one is the fifth paper with the paper ID 018. The paper title is The Effects of Data Reduction Using Rough Set Theory on Logistic Regression Model. The authors are Izati Rahmi, Rizwan Effendi, Nur Azah Samad, Hazmira Yoza, and Muhammad Wahyudi. Please welcome the presenter. You may turn on your microphone.
Thank you, Ms. Nur. I will try to share my screen. Assalamualaikum warahmatullahi wabarakatuh. Can you see my PowerPoint, Miss?
Yes,
Yes.
I can see a slide.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. First of all, in the insightful session of ACDM 2024, allow me to thanks for opportunity given to me to present my research article. I am Izzati Rahmi, the PhD student of University Pendidikan Sultan Idris, and our team are Dr. Rizwan Effendi, Associate Professor Dr. Nur Azah Samad, Hasmira Yoza, and Muhammad Wahyudi. Well, in this great opportunity, I would like to present my research article entitled The Effects of Data Reduction Using Rorschach Theory on Logistic Regression Model. And it is the outline of my presentation. The first one is about the background of this research. In this research, we have a study about the logistic regression. It is one.
I'm sorry, Madam Izzati, you can click slideshow for your slide.
I have.
Yes, that one.
Yes. In my view is have a slideshow.
Okay, it's okay. You may proceed.
If the view is have slideshow, Mrs. Nur?
I can still see your file with home insert draw tab. It's not a slideshow. It's not a slideshow.
Maybe we have to change to entire screen, right?
Yeah.
Now, please stop the presentation first and choose the entire screen, not window. And then choose the file.
Sebentar.
Entire screen and then choose the file or slide presentation.
Nggak kelihatan ya. I don't understand what's wrong with my Miss.
Okay, yes, it works. Madam Izzati, you may proceed. Izzati, are you talking? Or you may turn on your microphone.
Okay. Okay, I continue again. In this research, we have studied about the logistic regression. It is one type of regression model that appropriate for modeling a binary variable and may be extended for categorical variable with more than two categories. This method proposed in the early 19th century and is still widely used in the recent years. And the estimation of parameter in logistic regression is done by using the maximum likelihood estimator. Some previous study have found that there are some limitation of logistic regression. The first one is according to the estimation of the parameter. The logistic regression model is significantly affected by the presence of the outliers in the data and cause undue influence the results and the analysis and leads to incorrect inferences. And logistic regression done well based on several assumptions, but in some data, even though all assumptions have been fulfilled, the logistic regression model have low performance. On the other hand, there is another method that appropriate in analyzing categorical outcomes, namely Rorschach theory. This method proposed by Pollack in the early 1970s and still widely used in the recent years. Different with logistic regression, Rorschach theory approach uses only the knowledge presented by data itself and does not rely on statistical parameter and assumptions. And this method often compared and integrated with other classification methods, including logistic regression. And some previous study found that selective attribute by Rorschach theory can improve the performance of logistic regression model. And we have done some previous study to found the reset gap and problem statement. Rasidah 2022 found it that cleansing dataset by removing inconsistent sample using Rorschach theory can improve the performance of multiple linear regression. And another research found that using Rorschach theory for reduction, the attribute to improve the performance of logistic regression model, but no research that use Rorschach theory on data reduction by removing inconsistent sample. And Noraini 2022 found that attribute reduction not effective in low dimension data. So we found the research gaps. The first one, there is no research on data reduction by removing inconsistent sample for logistic regression models. And so there is an opportunity to study the effects of removing inconsistent sample using Rorschach theory and integrated the result for further analysis using logistic regression model. So the problem statement in this research, what is the effects of removing inconsistent samples using Rorschach theory to the performance of logistic regression model? And the next is the research frameworks. The first step in this research is procedure to data reduction. After we transfer the original data to information system, we will use Rorschach theory procedure for data reduction by removing inconsistent sample. And the next step, we will construct the logistic regression model. The first one for the original data or the model before data reduction. And we will produce the model that we call as original logistic regression. And the other hand, we construct logistic regression model after data reduction. That is the data after we remove inconsistent sample from the data. And we produce the new model that we call as logistic regression reduction Rorschach. And we also detect in the existence of outlier in original logistic regression. And if we found that there is no outlier, we will find that the final model is the same as original logistic regression. But if we found there are outliers in the models, we will remove the outliers and construct the new model that we call as removing outlier original logistic regression. And in the final step, we compare the performance of three models that we use. Next, the result of this research. In this research, we implement the proposed model in two data set. The first one is anemia data set, and the second one is the diabetes data set. In table 1 and table 2, we demonstrate the result for the anemia data. From table 1, we can see that there is a difference, the number of significant variable on the three model that we use. In the original logistic regression, we have two variables significant. We highlight the significant variable in this table. And in the second model, by removing outlier, we produce three significant variable, and the proposed model, we have four significant variable. And so we can see that in anemia data, the proposed model have more significant variable than the others models. And next, based on table 2, we can see the proposed model, logistic regression reduction Rorschach, have the highest performance for all indicator performance that we use for logistic regression model. We can see that logistic regression model is better than two others models. And next, it is the result of implements the proposed model in diabetes data. From table 3, we can see that the original model and the proposed model have the same, the number of significant variable, but different with the model with removing outlier. But different with the anemia data, in diabetes data, we can see that there is no significant difference with the value of a parameter in this model. So we can see that there is no significant difference with the effect of every variable to the existence of diabetes accident. And from table 4, we also conclude that proposed model still have the highest performance, the same as anemia data, but in logistic regression, in the diabetes data, the improvement of proposed model is fewer than the improvement for anemia data. And we can make some discussion and comparison with the empirical study. We can see from this table, in this research, we use two data that we assume have a different characteristic. The first one, anemia data, still contains quite a lot of inconsistent sample. Meanwhile, diabetes data contain little inconsistent sample. However, both the data set have a little outlier, less than 2%. So in the next discussion, we can see the effect of the number of inconsistent sample and the number of outlier in two data set. There are some comparison that we can see from the empirical study. The first one, the performance of logistic regression reduction rate, the proposed model, is better than original logistic regression and the model with removing outlier. And based on the number of inconsistent sample, there is a tendency that the more inconsistent sample, the greater the boost in the logistic regression model performance that results. And according to the number of outlier, both data contain a very small percentage of outliers, so that in both data sets, eliminating outlier only slightly improve the performance of the logistic regression model. And lastly, the logistic regression reduction rate model have a considerably higher number of significant variables than the removing outlier on original logistic regression model. So we can make some conclusion based on the results. The first one, the proposed model, the logistic regression reduction rate, can improve the performance logistic regression model better than the remove outlier original logistic regression. The second one, the growing logistic regression model performance on anemia data is substantially higher than on diabetes data due to the tendency that many inconsistent samples cause. Since the research is preliminary, simulation experiment must be conducted to confirm the findings. And well, it's all about my presentation. Thank you very much for your kind attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Izzati Rahmi, on your wonderful presentation for the title, The Effects of Data Reduction Using Rough Set Theory on Logistic Regression Model. Before we proceed to our next section, I would like to remind to all the presenters to have your presentation live. Doing it live because it grants you with a certificate. Unless you have some connection issues, then we will play your provided video. Thank you. So for the next session, I would like to ask whether Mr. Abdullahi O. Adleke is available. No. How about the paper ID 062, Muhammad Akmaluddin Ahmad Ramli? Not yet presented also. Then we shall wait around 2 minutes for our next presenter, Mr. Ye Chi Shen for his presentation at 2:45 p.m. Okay, it's already 2:45 p.m. Is Mr. Yachishan ready yet?
Hi, yes.
Yes, okay, let me introduce you first.
Okay, sure.
Okay, next, because the paper ID 044 and 0662 is not available yet, so we proceed to our actually the fourth presenter with the paper ID 007, and the title is Alleviating Sparsity to Enhance Group Recommendation with Cross-Linked Domain Model. The authors are Yue Qishen, Rosma Malmi Matnawi, Nurul Aida Osman, and Nur Ziyada Harun. Please welcome.
Okay, thank you. Are you able to see my screen?
Yes.
All right. Okay. So good afternoon, everyone. So it's an honor for me to present in this SDM 2024. So we are from the paper ID 007. The topic that I would like to discuss and present is alleviating sparsities to enhance group recommendations with cross-linked domain model. My name is Yui Qi Shen. So we have our co-authors, Dr. Rosma Mami, with us in this meeting as well. And these are our co-author, and we are from UTHM, FSKTM. Next, I would like to give an general overview of my presentations from introduction and research background, and then followed by literature review and research gap, up to result and discussion, conclusion, and last but not least, the acknowledgement. So next, I would like to start with introduction and the research background. So here is an overview of the recommender system. Okay, for the recommender system is generating recommendations based on the relevant historical data in a variety of applications such as YouTube, Netflix, or Spotify for recommending music that are frequently used to alleviate the data overload, because nowadays data are overload on internet. So this recommender system is actually helpful for us to choose our favorite items, such as for Netflix. It can help us to it can recommend movie to us, but they have also some limitation existed. So next, this is some general overview of the algorithm for the recommender system. They are basically separated in collaborative filtering and content-based. For collaborative filtering, which is our main used algorithm in our research. So it's basically using a data of similar user of their favorite items. So there is the connection with the similar users. So they are able to recommend the items based on the similar users. For the content base, is without similar users. It only identify some relevant items, such as there are similar movies, like there are action movies, or there are adventurous movies based on type and keywords, etc. So the most popular algorithm inside this collaborative filtering are singular value decomposition, SVD algorithm, and it is a matrix factorization approach. And this is also our main algorithms for our research. So for the content base is generally a classification algorithm like Bayesian classifier or a decision tree models. So next, I would like to give some research background about the group recommender systems, because there are many situations where it would be great if we can recommend to a group of users rather than individual. For most of the platform, we are recommend to end user, but there are some cases like choosing a television show for a group of users, or play a place of song to listen. There is based on some places like gym, etc. So there is a group of people inside the place, or selecting the destination for a group of traveler. So there are some situation it is helpful if we can generate the group recommendations for the group of users. So this is general overview of the evaluation pipeline, which we use a data set to train and test our model and improve, and with the end to improve the accuracy of the performance of our recommender system. And for collaborative filtering, we mainly using user, item, and ratings. For trend test, after that, we follow by the trend test split, and we split 20% to test set and 80% to training set, and we will generate the individual recommendations. So this a general individual recommender system. And the other way around, from the data set, we will also generate the groups. So we will perform the group generations, and then the synthetic groups will be generated. And for this, with this individual recommender system, actually we have the predicted ratings, and we have actual rating as well for the test set. So we are able to calculate the accuracy based on this predicted rating with the actual ratings. And then we will apply it into the group recommender system and generate the group recommendation to the group of users. So next, this is a general overview of the graphical representations of the ratings and also items user. Here is the user. So we are able to rate, this is a graphical representation of the relationship between user, items, and also the ratings itself. Maybe the thickness of the line is shows the highest favorite movie of them. And the red dotted line here is representing the missing value. All right. This missing value is actually can lead to sparsity problem. Okay. We also can represent this relationship of user, item, and ratings into a matrix, which is called user item rating matrix, in which we are able to translate the data meaning into this matrix representations. And the missing value here is actually cause the sparsities higher. So next, yeah, with a dense matrix, we are able to have most of the value being filled, but with a sparsities, with a sparse matrix that there are many missing value. So next, I would like to introduce some problems, general problem, and the most popular problem that exists in this individual and also group recommendation system. Because if a problem arises in the individual recommendation system, it's also certain that the group recommendation system also experience the same issue. And for our focus, we will focus to alleviate or reduce the data sparsities, because this is severely affecting the performance and also the accuracy of the predicted ratings. Okay, so since users only interact with a small portion of the item, because if we using Netflix to watch movie, we're not going to watch all of the movie inside the Netflix. So we are only able to like watch our favorite movies, etc. So and in that sense, we can give our ratings for that movie. So this will actually lead to the missing value in the system, and also the data sparsities issues will severely affect the recommender system. So there are many ways, like using algorithm or collaborative filtering, finding the similar users based on the similar users' favorite item, and recommend to the others people that have not yet watched that movie, etc. Okay. So next, okay, here is an general literature review and also our research gap that would help us. Based on our literature survey and literature review, we are these two methods are among the most popular, one of the popular methods that can alleviate the data sparsity issue, which the cross-domain methods is that, for example, if our target data set is movie, we would like to recommend a movie to other users. We are able to, we may choose like a books domain or music domain as our source domain, and transfer the knowledge inside this. I believe there are some hidden knowledge inside this data set, like book or music. So we can transfer our source domain knowledge into the target domain, which is the movie domain, and we can help in this help to alleviate the data sparsities and also increase the accuracy inside this movie domain, and we generate the movie recommendations to the users. So this is basically the cross-domain methods, a general review. And for the linked open data, is actually made up of the linked resource description framework RDF statements, and the metadata on the website like Wikipedia is described and also exchanged using these RDF statements. And we also focus on using DBpedia as our linked open data platform, because this is also the Wikipedia's RDF mapping, and also is an epicenter of the developing web of data. So we are able to extract the data that is not inside our data set. So we are able to extract using some algorithms to extract the data from this using this linker open data technology. So next, so our finding is that the research gap in our current existing research paper out there, there is only cross-domain recommender systems with LD technology for individual recommender system, and also cross-domain recommender system that are only applied for groups and after group formation. So there's no one like using the integration of both the cross-domain and LOD methodologies, I would say, before the group formations. So this is our novelty, I would say. Okay, so yes, so this is our research gap compared to the existing research paper, etc. Current research. So next, our methodology. I would like to explain a little bit about our research framework. As I said, for cross-domain, we will mainly using this the integration of linker open data and cross-domain, in which we transfer the knowledge from source domain, which is the music domain, and transfer the knowledge into the movie domain, in which we would like to generate the recommendations, the movie recommendations to our users. And this LD technology is actually enhance the hidden information. It's like there are hidden informations inside this. We are able to extract more data which can help to alleviate the data sparsity issues, like replace the missing value, etc. So this we extracted the data from DBpedia. As I said before, the DBpedia is a linker open data platform that we can use to extract the data from this online platform. So next, for the design and development, we will map the data in the target domain with LOD and source domain data, and then we will come up with an enhanced data with lower sparsities, which means the missing value is replaced by others data. So next, for this our design and development, we are able to develop our, I would say, our novel cross-linker domain models, which is an enhanced data in the target domain, which is movie domain. So next, we will apply it into GRS, collaborative GRS, which using the collaborative filtering and SVD algorithm. Then we will perform the evaluation for this system using like RMSE or hit ratio and DCG for ratings as well, for ranking as well. Thank you. So our experiment setup is we focus on using these two, Python and Neo4j. Neo4j is a data visualization, graph data visualization platform, and also we are able to use Cypher query for querying the data for the non-relational database data, in which is a graph database. So we are focused on using the MovieLens 1 million datasets, and this is the 1 million datasets, and the sparsity is quite high. The higher the sparsity means the missing value, the more the missing value. Okay. I would like to explain a little bit about this long tail graph of the MovieLens 1 million datasets. We can see from here, for the movie ID, not only less than 1,000 of movie have more ratings, like less than 500 movies have more than thousands ratings. So this is the general issues that cause the sparsities, because because most of the movies, the rating are very less, I would say. Okay. So this is the general cause of the sparsity issues. Next is our algorithms that we used to generate our cross-linker domain models in an individual recommender system before the group formations. Right. This is a pseudocode that we use 3 feature. We extracted this movie composer from music composer from music domain, and using linker open data. And also we are able to extract this director and styling feature, which is not initially inside the MovieLens 1 million datasets. And we extracted these 3 features and also from music domain using LT technology from DBpedia. And we use the Sparkle query to extract this linker open data. And we use some one-hot encoding because this is the categorical data, so we use the one-hot encoding for this music composer and director. For styling, we will also do the binary representations for this. Okay, and then we train the data sets, and then we come up and result. Okay, so before we extracted the 3 feature from linker from DBpedia using linker open data technology, and also we extract the data from music domain, is that we can see that this is not much linked between each other, each node. But after that, we extract this director and styling feature using linker open data technology from DBpedia, and also we also using this linker open data technology and extract the data from music domain, other domain, as our source domain. So this is, we can clearly see that the comparison between before and after for these linkers. So we can see that there are many hidden layers and also hidden relationship between other than users, movies, and ratings. So this is the one of the ways to increase the performance of the recommender system and also increase the accuracy. Okay, next. So from our experiment result on this effectiveness of utilizing both the integration of linker open data and cross-domain in the individual recommender system before group recommendation. Before group formations. So this is the this is the evaluation metric that we use, which is the error, the 3 error for better comparison. Okay, so this is the first one we experimented it using original MovieLens 1 million datasets. The error is higher because the higher the error means the lower the accuracy, which means the performance is not that well. But if the error is the lower, which means the accuracy is more high, and the performance is good, and we can say that the recommendations is can tackle the user's preference. So after we choosing from the same domain with director and styling feature music domain, we can see that actually the error is lowered a bit. We can see the changes. And also if we only using this from other domain, cross domain, but without additional feature, we also can see that the changes compared to the original, which the higher error existed. And after I applied with three additional feature, which we extracted using the linker open data and also from the cross domain, and the error is actually the lowest, which is the best performance and also the highest accuracy. So this study is also aimed to alleviate the data sparsity before the group formations process is carried out in the GRS, because this is tested in the individual recommender system. So next, I would have some conclusion for my presentations. So our proposed methods is leverage which means we utilize the auxiliary decoupled data and cross-domain features simultaneously during the model training using SPT algorithms. And we also use the enriched data to make the rating predictions to replace the missing value, etc. And for our enhanced data, it actually can be used to form a user profile for further group formations and to provide a better group recommendations to groups. As we can see that the result just now for the integration of these three features is actually the best performance and also the best result, the lowest error, the highest accuracy. So the results of our study is that our studies and our methodology was superior compared to using a sparse data given as the original unenriched data sets, because we have an enriched data sets after we utilize our methods, which we integrate the LLT and cross-domain features. So our study also suggested a more accurate predictions of the missing values, for the missing ratings in the original data sets. And it showed data sparsities was alleviated in individual user profile before the group formations to provide a more effective group recommendations in the future. So I would like this is our acknowledgement. So our study was supported by the MOHE through the FRGS. Okay, and we would like to express the gratitude to UTHM for providing the financial assistance, also assistance during the literature search throughout this study. So I would like to end my presentation. So thank you, everyone.
Thank you, Mr. Ye Chi Xuan,
Well-
for the interesting topic. I hope that you'll be success until your graduation. Sincerely wishing you. Thank you.
Yes, thank you.
Okay. For the next presenter, we will proceed with paper 062 with the title Optimizing Team Formation for Welfare Activities, a study using 4 meta-heuristic optimization algorithms. The authors are Muhammad Akmaluddin Ahmad Ramli and Roslina Mohammed. Please welcome the presenters. Oh, unfortunately, they are not around, so it will be presented with a video.
This is my presentation for my paper, which is an optimizing team formation for welfare activities using 4 meta-heuristic optimization algorithms. So let's going on. So this is the background of the traditional team formation system, which is it caused a lot of problem, which is first the heterogeneity among volunteers, second is poor team coordination and communication, third is lack of resources, and last one is lack of training and support for volunteers. So this is the common problem when for a normal team formation system. So this is what inspired me to do this research, to make a lot of improvement for this particular problem, to solve this. So this is the existing algorithm that usually be used for these team formation problems. So this is the 4 biggest or most used and common optimization algorithm that we use, which is the sine cosine algorithm, the Jaya algorithm, and the particle swarm optimization algorithm. So this is the 4 chosen meta heuristic optimization algorithm that I choose to make an analysis for which is the better one and which is the not the best for these particular cases. So the sine cosine algorithm is this technique is inspired by the behavior of the sine and cosine functions, focusing on population based on optimization. So next one is the Jaya algorithm. it is a continuously improved solutions for optimization problems by refining a group of candidate solutions and over iterations. So next is the Firefly algorithm, which is it is inspired by Firefly's behaviors and their like patterns. Jin Shiyang introduced it in 2008 as a method for solving optimization problems. So the last one is the particle swarm optimization algorithm, which is the modeling bird flocking behavior. This method adjusts the positions of particles representing potential solutions to navigate through the optimization search space. So this is the methodology that I use to finish this research, which is there's three phases. First one is the planning, second one is the development, and the last one is the evaluation phase. So in the planning phase, I identify the research. We select the literature papers that related to this research from various type of website that provide us the literature papers, and we make a data synthesis. So next phase is the development phase, which is we attribute analysis. We identify the algorithms, which is the four meta heuristic algorithm, which is the sine cosine algorithm, Jaya algorithm, Firefly algorithm, and the particle swarm optimization algorithm. So after we identify the algorithm, we identify the algorithm attributes and forms. Then we analyze the algorithm attributes. So next is the system development, which is the development of the system itself. We select the algorithm to develop the system, and we develop the system required based on the algorithm chosen. Then we apply the system for JKM volunteers because we use JKM volunteers as the data set for this research. So next is the evaluation phase, which is we establish the data set, we run the code, and we cluster the data based on the criteria needed when we run the code again. So then we modify the algorithm forms and we run the code, and we make the final analysis for the results. So this is the environmental impact that might be might impact to the software development goals, the SDG. So the first one is the decent work and economic growth, which is the goal for an efficient team formation can lead to cost savings for welfare organization, enabling them to allocate financial resources more sustainably. So the next one is to reduce inequalities by promoting equal opportunities for participation and ensuring that marginalized groups are included in welfare activities. So this is a demonstration for the system for this research. So this is the system that I developed. So the first thing we need to do is we need to extract the skill from the data set. So this is the skill set that included in this data set. So there is 1,000 people, experts, and there are 75 different unique skills among the 1,000 volunteers. So next is we need to extract the cost between each volunteers. So this is after we extract the cost, it will become like this until the person 1,000. So after we done extract the skill and the cost, then we can do the team formation for the 4 algorithm. Okay, so this is the team formation using Ajaya. This is what the outcome, which is there is the cost for the best, maximum, and average for the member and the team cost, and the total running time. So this is the team formation using sine cosine algorithm. and the same. This is the total running time and the team cost. This is the Firefly algorithm, and this is the particle swarm optimization algorithm. So based on this result, we do this for 10 times, 20 times, and 30 times to make sure the analysis is accurate, and we visualize it into a graph in the research paper. So you can check it in the research paper. So that's all from me. Thank you.
Okay, thank you, Mr. Mr. Muhammad Kamaluddin Ahmad Ramli. The title Optimizing Team Formation for Welfare Activities, a study using 4-meta heuristic optimization algorithm. Quite an interesting topic, as it's quite similar to my ongoing research right now. So next, we are going to invite our next presenter with the paper ID 044. The paper title is Improved Classifier Chain Method based on Particle Swarm Optimization and Genetic Algorithm for Multi-Level Classification Problem. The authors are Abdullahi O. Adleki, Noor Azza Samsudin, Shamsul Kamal Khalid, and Rizwan Effendi. Please welcome.
Hello, Assalamu alaikum and good day everyone. My name is Adeleke Abdullah. I'm here to present our research title Improve Classifier Chain Method based on Particle Swarm Optimization and Genetic Algorithm for Multi-Level Classification Problem under the following authors. These are the presentation outline, introduction, motivation, objective, methodology, result, and discussion, and finally the conclusion. Now, introduction. Text classification. Our research is within the domain of text classification. Text classification is an important field within the area of machine learning. It focuses on mining information from text. It focuses on how we can model predictive algorithms to take instances from a textual data and make predictions. Within the premise of text classification, we have the single label classification as well as the multi-label classification. Our research is within the area of multi-label classification. Multi-label classification simply is an extension, like I said, is an extension of the traditional single label classification. It simply involves the task of modeling instances of data to predict from more than one class label simultaneously. And this is what makes it to be different from multi-class classification, which simply involve modeling predictive algorithms to make predictions for more than one class as well, however not simultaneous. So multi-label classification has been widely applied to several problem domain, and over the years there are several algorithms and techniques that have been developed within the area of multi-label classification. One of them is the classifier chain algorithm. Our research focus on improving on the conventional classifier chain algorithm. So the conventional classifier chain algorithm, CC, it's a very important multi-label classification algorithm based on the technique of problem transformation. It works by training K classifiers, and it predicts a new instance of a data based on the label sequence of the classifier chain. Now, classifier chain has a advantage of being simple to model. However, it has a major challenge, and that challenge is that the classifier chain algorithm, it fails to recognize a distinct, unique label sequence order within the chain. What it does is that it models the classifiers randomly. It uses what we call random label sequence order for the classifiers modeling within the chain. And studies have shown that this random label sequence ordering, it has negative influence on the predictive performance of the classifiers. So for this purpose, our research attempts to address the random label sequence ordering within the classifier chain. One of the reason why the random label sequence ordering needs to be addressed is due to the nature of how the classifiers are arranged in a chain-like structure. There's going to be what we call label dependency, or otherwise also known as label correlation. What this means is that the classifiers depend on one another within the chain for their predictive tasks. So once there is an error, in one chain, in one classifier, then it goes along the chain, and this is what we call error propagation, which eventually reduce the performance, the classification performance of the algorithm. So our research attempts to address this problem in with the end goal of achieving optimized, improved performance, classifier performance. So the objective, like I said, is to extend the traditional classifier chain algorithm, taking into consideration the random label sequence order, and to experiment the proposed method using multi-label data sets. In the methodology, the data at first is preprocessed using standard preprocessing techniques, which is the string to word vector and term frequency, inverse document frequency. These are some of the conventional preprocessing techniques often employed in machine learning problem. And the methodology is an hybrid, is a combination of particle sum optimization and genetic algorithm. So the genetic operators of GA are integrated into the particle sum optimization, and the end goal is to combine the strength of PSO to combine the natural selection process of swarm intelligence like PSO with the explorative capability of genetic algorithm. The benchmark data sets, as you can see, environment-based LLOG, yeast, and Slasher were experimented in the course of this research, and the result of the proposed method is compared with that of binary relevance as well as classifier chain. This is the proposed PSO GCCC algorithm. The input is a training set, and the output is the optimized label sequence within the classifier chain. Now, it starts by initializing population of particles which are potential candidate solution to the given problem. It initializes the population of particles with random positions and velocity, as well as swarm size, and it also sets the previous best solution to the current best solution. Now, it partitions the training set into two parts. We have the build set where the chain classifier will be modeled, and we have the validation set where each of the particles will be validated based on the validation equation. Therefore, all particles in the solution is going to do, what will it do? It's going to construct the system model using the build set and the label sequence, and then it will now compute the fitness for each particle within the system model using the validation set and the fitness function. Then it will keep iterating itself and updating the population p-best and set that to the g-best. And eventually, it's going to take the improved final solution. It's going to improve the final solution of the current population using from PSO using GA. So that works for all individual in the current population. What will it do? It's going to evaluate the fitness, which is the quality of the solution, using the fitness function that is presented in the paper, and it's going to apply genetic operators on the fitness on the solution. It starts by using what we call tournament selection approach. What this does is that it selects the parents that is going to come together to form the offspring. And the parent will be selected based on the particle with the best fitness value, that is what that was previously evaluated. Then it will generate new particles, which is a child from the old ones, the parent, using the crossover operator. Now it's going to apply the mutation procedure on each of the particles that have been generated, and eventually it's going to update the particles and population using elitism H-based replacement approach. The elitism H-based replacement approach, it works by taking a few best solution and replacing the entire solution with a few best solution. It iterates this until the maximum iteration is reached, which is of course the number of generations that is carefully defined. Then it will now return the global optimal solution, which is the best solution to the given. Now, under the result and discussion, the study employed the use of heuristic evolutionary based techniques for improving the predictive performance of standard multi-label classifier chain method. Like I said earlier, it is an hybrid of particle sum optimization and genetic algorithm, and it was experimented on 6 multi-label classifier benchmark data set. In addition, decision tree forms the baseline single label classifier. The experimental results were presented in tables 4.1 to 4.8, and the result of the improved method was compared against CC and BR. As you can see from the results, we tested the proposed method with BR and CC in terms of accuracy, in terms of exact match, in terms of AMI loss, in terms of recall and measure, in terms of geometric mean, and finally in terms of degree of balance. And consistently, as we saw in the course of our experiment, consistently the proposed method achieved overall accuracy across. Using the GEM-based data set, it achieved above 90% accuracy results. The method performed, however, it performed poorly using the LLOG data set. This is actually due to the nature of the data that is being experimented. In conclusion, our research was able to improve the predictive performance for multi-label classification problem. We were able to propose an extension of the conventional classifier chain method based on hybrid of heuristic techniques of evolutionary algorithms. It enabled the searching of a distinct single label sequence order, which is different from the random label sequence order that we earlier established to have negative influence on the predictive performance of the classifier. And the study showed that the potential of the PSO-GCC against the conventional CC method was established. These are some of the references used in the course of this research. Thank you.
Thank you, Mr. Abdullahi Adleki, on the presentation. Next, we are moving on to our next presenter with the paper ID 072. The title is Portfolio Optimization with Percentage Error-Based Fuzzy Random Data for Industrial Production. The authors are Muhammad Haris Hakal Othman, Norizi Arba'i, Muhammad Shukri Chetlah, and Pei Chun Lin. Please welcome.
Welcome to my presentation on portfolio selection using fuzzy random data, specially tailored to the Industrial Production Index. The primary goal is to match investments with financial objectives and risk tolerance, ensuring that the investment align with personal or organizational goals. A well-balanced portfolio allocates funds strategically to maximize potential profits while maximizing risks, creating a robust financial plan. Traditionally, approach like Markowitz mean variance methodology have been employed to achieve optimal returns. However, this method often rely on single point estimation and conventionally probability theory with may not fully capture the complexities and uncertainties of the real world. In this presentation, we will explore more advanced technique and address this challenge. In the real world, data is often imprecise and filled with uncertainties. This can stem from various factors like measurement error or inherent bias. Additionally, the complexities increase due to the physical randomness and human ambiguity, making it difficult to rely solely on traditional methods. To address this challenge, we introduced the fuzzy random data approach. This method designed to handle uncertainties in portfolio selection effectively incorporate both fundamental and technical elements into the decision-making process. Traditional methods, however, have their limitations. They typically rely heavily on historical price and volume data, often including other potentially relevant data sources. This can result in an incomplete analysis, missing out on critical information that could impact portfolio performance. In recent years, we have seen significant advancement in modeling techniques that better manage uncertainty. For instance, fuzzy sets and interval values are used to handle the inherent unpredictability of real-world data. Examples of these include fuzzy hidden Markov model and decision-making framework like FANP and FAHP, which offer more robust approach for uncertainty management. These advancements have led to improved portfolio selection methods by integrating randomness and fuzziness through fuzzy random data models. It will enhance the accuracy of our predictions. This approach helps in filling crucial gaps in traditional uncertainties managed, leading a better informed investment decision. Our proposed methodology leverage this advancement by utilizing fuzzy random variables to tackle both randomness and fuzziness. We employ a systematic data pre-processing method that uses confidence interval defining by min-max values to ensure a comprehensive approach to data analysis. This presentation is structured to guide through the key elements of our study. Section 2 covers the literature review where we explore existing research and methodologies related to the portfolio optimization. Section 3 introduces our proposed method for portfolio optimization, detailing the innovative approach we developed. Section 4 presents a practical example using data from 5 industrial sectors, demonstrating how our method works in real-world scenario. Section 5 concludes with our finding and discussion future direction for further research and application. Mean variance model. Overview of portfolio selection. Mean variance model serve as foundation framework in portfolio selection, aiming to balance risk and return in investment portfolios. This strategy is commonly employed in financial decision-making, guiding investors to optimizing their asset allocation. Next is improvement to the model. Over time, the model has undergone significant enhancement to better address real-world uncertainties. This improvement allows it to incorporate more dynamic and realistic factors that affect investment outcome, leading to more informed and effective portfolio management. In this slide, we delve into the mathematical representation of the portfolio selection model defined by equation 1. The objective function aims to minimize total portfolio risk, represent as follows. Minimize total portfolio risk. Minimize the sum from I equal to n of the sum of j equal to n of x sub I times sigma sub ij times x sub j. In this equation, x sub I represents the weight of investment, while sigma sub ij denotes the covariance between the returns of asset I and asset j. The goal is to find the optimal weight that minimize the overall risk of the portfolio. Next, we have the constraint of the model. The first constraint ensures that the portfolio meets the expected return requirement. The equation is subject to the sum of I equal to n of E of R sub I times X sub I equal to rho. Here E of R sub I signifies the expected return for each asset, and rho is the desired return for the overall portfolio. This constraint ensured that the expected return aligned with the investor's goal. Finally, we have the total investment constraint. The total investment constraint, the sum from I equals to 1 to n of x sub I equals to 1. This constraint ensures the sum of the investment proportion equals 100%. It's also crucial that the weight of the investment are non-negative. X sub I is greater than or equal to 0 for I equal to 1 to n. This condition guarantees that no short selling is involved, meaning that all investment must be non-negative. This mathematical framework forms the backbone of our portfolio models, selection model, guiding the optimization process while considering both risk and return. In this slide, we explore the concept of fuzzy set and fuzzy random variables. Fuzzy set provide a way to represent uncertainty and ambiguity in data. A fuzzy set A is defined with a universal set U using a membership function M sub A. This membership function assigns a degree of membership ranging from 0 to 1 to each element in the element X in U. This degree indicates how well each element satisfies the characteristic property of fuzzy set. The formal representation of a fuzzy set A is given by A equals the set of orders pair X M sub A of X, such that X is an element of U. This script outlines the definition and representation of fuzzy set, laying the foundation for understanding fuzzy random variables. What are fuzzy numbers? Fuzzy numbers capture uncertainty and ambiguity, making them useful for real-world situations where precise values are hard to determine. A fuzzy is described using a membership. The equation is M sub A of X equal the summation from I equal 1 to n of M sub I of X times I sub A sub I of X. M sub A of X is membership function of fuzzy set A for element X. The summation from I equals 1 to n is adding up the term for each I of M sub I of X, and it's a membership function for element X in fuzzy set A sub I. Why use fuzzy number? Fuzzy number allow us to represent uncertain data more realistically, which is especially helpful in fields like finance, where many factors are unpredictable. Definitions of normal fuzzy sets. Set A is considered normal if there exists at least one element X in the universal set U, such as that the membership function M of X equal to 1. This indicates that there is a minimum range degree of membership in the fuzzy set. Fuzzy random variables. Fuzzy random variables are introduced as a hybrid of fuzzy data and randomness. This allows for a better representation of uncertainty by combining the concepts of fuzziness and randomness. The improvement in the concept enable the use of generalized integrals for set value function, enhancing modeling and modeling capability. Central limit theorem for random variable with mean and variance. The central limit theorem states that when you have a large number of independent random variables, their standardized mean will approximate a normal distribution regardless of the original distribution of the variables. This is crucial in statistics because it allows us to use normal distribution method for inference even when the underlying data does not follow a normal distribution. The standardized sample mean, the equation for the standardized mean is such follow, where Z sub n represents the standardized value of the sample mean. N over 1/2 is a square root of the sample of n. X bar sub n is the sample mean and m is the population mean. The formula effectively standardizes the sample mean by subtracting the population mean and dividing by the standard deviation, which allow for comparison across different samples or populations. Coverage in distribution. As n approach infinity, the standardized sample mean Z sub n coverage in distribution to standard normal distribution. This means that for a large enough sample size, the distribution of the sample mean will closely resemble a normal distribution with a mean of 0 and a variance of 1. This property is foundational in many statistical analysis, including the hypothesis testing and confidence interval. The importance of fuzzy theory in portfolio selection. Traditional models, such as Markowitz mean variance model, rely on precise estimates of return and risks. They assume that all inputs can be known exactly, which is often not the case in real scenario. Real-world data challenge. In practice, financial data is often characterized by uncertainty, ambiguity, precisions. Factors such as market volatility, economic change, and unforeseen events contribute to this uncertainty. Fuzzy theory framework. Fuzzy theory offers a framework that incorporates this uncertainty into the decision-making process. By using fuzzy sets and fuzzy random variable, it allows for the representation of data that is not strictly precise, providing a more realistic model for portfolio selection. Our proposed model, which is structured in two distinct phases. To phase fuzzy random data integration, the first phase focuses on integrating fuzzy random data. This means that we capture both the fuzziness and randomness inherent in real-world data. By doing this, we can better represent the uncertainty associated with different investment options. The portfolio selection model. The second phase involves applying this integrated data within a portfolio selection model. The aim here is to optimize portfolio strategies across various production types, ensuring that we take it into account both randomness and ambiguity in the data. By addressing randomness and ambiguity, this approach is not only enhance the accuracy of our portfolio selection, but also improve decision making in uncertain market conditions. By systematically addressing these challenges, we can develop more effective investment strategies that adapt to the complexities of the financial landscape. Now, we will move to methodology section. Portfolio selection model using fuzzy random data. In phase 1 is the data pre-processing. In this phase, we focus on preparing our data to better handling uncertainty. We employ fuzzy random variable which allow us to represent data that is both ambiguous and random. This method captures the inherent uncertainty in real-world data, ensuring that we account for variability and potential fluctuation in our inputs. In phase 2, utilization of enriched data. After the data has been pre-processed, we move to this phase where we apply the enriched data within a mean variance framework. This approach allows us to optimize our portfolio strategies effectively. By using the equations, we analyze how different production types can be managed in a way that balance risk and returns, it enabling better investment decision. This two-phase framework effectively addresses the complexities of real-world data, providing a structured approach to portfolio selection that incorporates fuzzy random data. Fuzzy random data pre-processing. The main goal of this pre-processing stage is to effectively capture the real-world uncertainties present in production data. This ensures that the analysis considers the variability and potential inaccuracies inherent in the data collected. To achieve this, we employ a methodology based on measurement error range following established technique from prior research. This involves converting single point data into fuzzy set, which represent the data in a way that accommodates uncertainty. Specifically, we assess the maximum and minimum production value to create fuzzy sets that reflect possible variance in the data. By doing this, we generate a more accurate representation of the production data that accounts for natural fluctuation and uncertainties that may occur in real-world scenario. This approach lays a strong foundation for the subsequent phases of our portfolio selection model, ensuring that the data we work with are robust and reflective of real conditions. For each data point, we define two critical values: minimum potential value and maximum potential value. Minimum potential value represents the lowest value that data point can reasonably take, and the maximum potential value is represents the highest value that the data point can reasonably take. To calculate this value, we use this following equation. For minimum value equation, such as this value where IP index production value and P is percentage of error. And for the maximum value is IP is index production value and P also the percentage of error. This calculation transform a single point production data into fuzzy intervals by adding and subtracting a percentage of error. This provides a range of AI and BI that better capture the uncertainty in the data, making it more realistic for analysis and decision making. The original data is transformed into fuzzy intervals to better reflect real-world uncertainties. Each fuzzy interval represents the potential range of the corresponding data point, capturing both the minimum and maximum possible value. First is center point. It represents most likely outcome of an interval, and second one is width, indicates the level of uncertainty associated with the data point. The transformation into fuzzy interval allows for a more nuanced representation of the data. The center point provides a point estimate of most likely a value which can be used for decision making, and width is quantify the uncertainty around estimate, giving decision making insight into the potential variability of the data. This approach enhances the robustness of analysis by incorporating uncertainty, making the model more applicable to real-world scenario. The portfolio selection model is defined such follow. In this formula, the goal is to maximize expected return represented by the summation of I equal to 1 to n of E of C sub I times X sub I. Simultaneously, we minimize the expected risk indicated by summation of I equal to 1 and n of E of W sub I times X sub I. The total investment must not exceed 1. Each investment proportion must be non-negative. This dual optimization approach ensures that while aiming for higher returns, the model also accounts for associate risks, providing a balanced portfolio strategy. By using expected value derived from fuzzy random data, the model enhances decision-making in uncertain environment, particularly in industrial production context. This is the optimized approach. First is data collection. Gather relevant production data necessary for the portfolio analysis. Second is determine measurement error. Set fuzzification limits to quantify the uncertainty in the data, such as 1%, 3%, or 5%. Next is fuzzification, a calculate interval. Next, we compile the result, present the fuzzified data interval parameter, such f sub I equal to open bracket A sub I comma B sub I close bracket, represent the potential range of each data point. Next is calculate the probability distribution function. Distribution function is to analyze the fuzzified data to determine the appropriate distribution type for the modeling the uncertainty. Next is optimize the portfolio. Apply the portfolio selection model to assess risk and returns, utilizing the formulate equation to achieve optimal investment strategies. This optimized approach offers a structured method for decision makers to develop robust portfolio strategies while effectively managing uncertainty in industrial production data. Now, we will move to numerical experiment. In this session, we analyze data from 5 distinct production sector such agriculture, mining, manufacturing, electricity, and water. The data is obtained from Malaysia official data catalog, which can be accessed at data.gov.my. The dataset has spans a 3-year period from 2015 to 2023. The primary goal of this study is to identify an optimal investment portfolio by selecting one of these 5 production sectors. This analysis aims to evaluate the performance and potential return of each sector, providing insight of investment decision by leverage data over multiple years. We can assess trends and variance with each sector, allowing for the more informed selection process in our portfolio optimization model. Fuzzy random data pre-processing start here. The raw data obtained in table 1 is then fuzzified by using 5% measurement error based on the equation. This results in fuzzy interval data in A form of AB, where A is minimum data and B is the maximum data. Table 2 shows the percentage error data. After the data have been processed using the percentage error, the data should be fuzzified data to center point and the width. After the data has processed, it should represent such in the table 3. Following data collection, we calculate the center point and width of the fuzzy data as shown in the table 4. To address randomness, we employ the probability distribution function for each production sector, generating various distributions such as normal, log, gamma, and Weibull. And their corresponds is p-value. The data distribution with the highest p-value is selected for each data type to best represent randomness. Table 4 represents 5 production sector in the form of x1, x2 to xn. The table 3 highlights the probability distribution with the highest value, logistic, Weibull, and gamma. The moment estimator are used to approximate the expected value and variance for each sector as detailed in table 5. Once the final production index value are calculated, this processed data is input into the portfolio selection model to identify the optimal portfolio accurately. The portfolio selection model in the equation is used to build the model. The equation is resolved using a linear programming approach. Here we assume that K represents the risk level and the optimal solution is achieved with Xn. The model computation halts upon reaching the optimal solution. Using the fuzzy random data in the table, the mean variance model employs expected value in the objective function to attain a desired amount return, while it uses variance in the constraint to control the portfolio risk or volatility level. Table 6 shows optimal solution result. From the result table, the risk is K is 5.5991, indicate the optimal solution where the expected return is 7.03 and 2.58 for the 5% percentage error. The optimal result is based on the 5 industrial production data in manufacturing production. The risk level K is crucial for guiding management in portfolio selection. In table 6, the optimal value X indicates the associated with a specific portfolio. Here, the manufacturing output is projected to yield the highest return among the production sector, a belt with the greater risks. The primary aim of this research is to identify industrial production solutions that offer high return while managing risk. The risk level at K3 and 4 and 5 is generally linked to the positive expected return, but K 5.591 show the highest potential return according to the table 6. This model helps management focus on industrial risk, the best risk return profile for maximizing profitability. For the risks of K equal to 6, ideal portfolio is already established. As risk tolerance increase, the optimization algorithm adjusts the portfolio to minimize the risk while maintaining the desired return. For instance, to increase the risk from K to equal to 6, the allocation X2 is reduced by 0.651 units, while the X3 is increased by the same amount, leading to a shift in portfolio allocation that reduces overall risk. Lastly, in conclusion, we introduce a novel method that integrates fuzzy random data to better handle uncertainty inherent in real-world data by combining fuzzy random variables. Our approach addresses the complexities faced in portfolio selection. Additionally, we utilize a mean variance framework for our portfolio selection model. This framework allows for optimized portfolio strategies tailored to various production types, ensuring that our solutions are not only effective but also relevant across different sectors. The results from this approach demonstrate its resilience and adaptability. We applied our model to 5 distinct production sectors, yielding optimal production insight that facilitate strategic decision making. In summary, this methodology significantly enhanced our ability to manage uncertainty in portfolio selection, establishing it as a valuable tool for industrial production planning. Thank you for your attention. In this presentation, we explore a new approach to portfolio selection that integrates fuzzy random data, enabling better management of uncertainty in real-world application. Our findings underscore the importance of utilizing advanced modeling techniques to enhance the decision-making in industrial production planning. I hope this work inspires further research and practical application in the field. If you have any question or would like to discuss this further, feel free to reach out. Thanks you once again, and I look forward to your insight.
Thanks to the presenter for the wonderful and detailed presentation on the title. Next, I'm going to ask first whether the paper ID 051, does any of the authors around? Would you like to present live or using your video? We have Mosleh, Ahmad Adil, Ali Al-Hamza, and Muhammad Anbar. Okay, so far there is no any response, so we shall proceed with the video provided. Next, a presenter would be the paper ID 051 with the title Performance Evaluation of Whale and Harris-Hawk's Optimization Algorithms with Intrusion Prevention Systems. The authors are Mosleh M. Abu Al-Haj, Ahmad Adil Abu Shareha, Ali Al-Alawi, Al-Hamza Muntir, and Muhammad Anbar. Please welcome.
Hello everyone. I'm going to present a paper for the SCDM 2024 conference. The title of the paper is performance evaluation of well and house optimization algorithms with intrusion prevention system. I am Prof. Muslah Abdul Haj from Al Ahliya Amman University, Amman, Jordan. As we know, a considerable number of people lives rely on the cyber world. However, cyber world faces serious cybersecurity issues. Some of these issues or threats are like malware and phishing and many others, of course. Therefore, cybersecurity engineers should provide us with tools to countermeasure these attacks. Some of these tools, antivirus, firewall, and intrusion detection systems, and many other tools. So what is intrusion prevention? It should be prevention, not detection. What is intrusion prevention system? IPS is a network security appliance which inspects all inbound and outbound network traffic for suspicious patterns that could indicate a network or system security breach. For example, if attacker want to attack my server at the site, the traffic will go first through my IPS. The IPS will check this traffic, and if it's attack traffic, will prevent. That's why it's a prevention. No? Will prevent the attack. So this is the main role of the IPS. The current attackers use very advanced techniques, or the attackers use very advanced techniques. These techniques mainly based in AI. Therefore, the tools that designed by the engineers also should use AI to mitigate the attacks or the advanced attacks that launched by the attackers. So the current IPS uses the machine learning techniques. Machine learning is part of AI. Machine learning techniques to detect the attacks, to prevent the attacks launched by the attack. What is machine learning? Machine learning, in short, allows the computer systems to learn from the available data, the history data, to predict the future attacks. So this is in short what is a machine learning. However, one of the issues that faces the machine learning that it has to handle with large size data. So when the data is very, very large, the performance of machine learning algorithms will be degraded. Therefore, we need to reduce this large data. Part of machine learning algorithm are feature selection algorithm. Feature selection algorithm are used to select only the important features attacks, the data that allow us to identify the attack. For example, if we have 100 of features in our data, feature selection algorithm will, for example, reduces these features to only 10 or 20 based on the user algorithm and based on the data we have to 10 or 20. These 10 or 20 features, the important features which we can rely on them to identify the attacks. And the other features are like less important. So we remove them. In this case, the size of the data will reduce and the performance of the machine learning algorithm will be enhanced. So there are many feature selection algorithms. Two common feature selection algorithms are WOA algorithm and HHO algorithm. These two algorithms will be used in this paper to select the features or the important features related to the attacks. And we will compare the result when we apply each of these features, and we will find which algorithm is better with IDS or with IPS, intrusion prevention system. This figure summarizes our work in the paper. This is the model we designed in this paper. First, we will use the NSLKD dataset which is very well-known dataset for the IPS. It contains 40 features. These features need to be pre-processed. First, we apply data transformation using label encoder algorithm to transform the text data to numbers. Then we apply a min-max scalar algorithm to normalize the data, that is transform the data to certain ranges or to same ranges, not very wide ranges. Then we apply the HHO algorithm on the SLKD dataset, and we apply the WOA on the SLK dataset. The HHO selected only 13 features from 40 features. The WOA selected 16 features from 40 features. So to find which algorithm selected the best features that identify the attacks, HHO or WAA, we use the KNN classifier. This classifier will be used to compare these three algorithms. And we will use again these 5 metrics to see which algorithm is better than the other. The result, when we use KNN with HHO and WOA, shows that both algorithms achieved a very good accuracy. However, WOA achieved a slightly better accuracy than HHO. Therefore, we can say both algorithms are good. However, WOA is slightly better than HHO in detecting or in preventing the attacks when it used with IPS system. Thank you. This is all for this paper.
Okay, thank you, Mr. Mosley, for the presentation on the Whale and Harris-Hawkes optimization algorithm. Before I proceed to the next session, I would like to ask whether Mr. Abdul Rahman is available now.
Yes.
Yes. So, are you okay to proceed to your presentation?
Yes, for sure.
Sure. Thank you. So, please welcome our next presenter with the paper ID 052. The title is Domestic Solid Waste Prediction with an enhanced LSTM with Sigma RELU and RADAM optimizer. The authors are Abdul Rahman Sharaf Muhammad Fadil, Wazaida Ghazali, Muhammad Razali, Muhammad Tomari, Yana Mazwin Muhammad Hasim, Abdullahi Abdi Abu Bakar Hassan, and Lokman Hakim Ismail. Please welcome the presenter. Thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. This is Abdurrahman Sharaf Ahmad Fadl, and today I'll present our research paper, which is held entitled of Domestic Solar Waste Protection with Enhanced LSTM with Sigma ReLU and RADAM Optimizer. First, the research area is consist on the waste management, and as known, in a modern city and countries, population continue to grow and the volume of waste generated as well continue to increase, which is making the management waste system in a critical challenge for cities worldwide. And this effective waste management is essential for maintaining the landfill area and public health, environment sustainability, and and open clean lines. And that's lead to the importance of making a protective model in a waste management. And the advantage of it is to manage the waste collection effectively and to make an accurate prediction of waste generation is critical and important. And these predictions help in optimizing a collection schedules, allocating the resource effectively, and minimizing the environment impact. And here where the deep learning play the roles. And the role of deep learning is by the traditional statistic method for waste forecasting is often full, short to the complex and variability of waste generation patterns. And the deep learning models are widely known and used in protective model, especially like LSTM network, which is showing the promises in capturing these patterns and provide a more accurate forecasting for long and short-term memory. Therefore, the existence LSTM in deep learning consists of some challenges, and these challenges stand for the Fisher gradient issues, and especially in ELSTM, the gradient can become extremely small during the backpropagation and training, and this lead to a poor learning and long-term dependency not being captured effectively. And other than the Fisher gradient, there's the unstable learning rate. So in existence, LSTM model often it face some difficulties with coverage during training, leading to some learning rate issues that can be lower the model performance. And last but not least, existence LSTM is suffering from the overfitting issues. And during the LSTM's training, LSTM networks, especially when trained on limited or noisy dataset, it tend to overfit and it capture a noisy instead of meaningful patterns, which reduce their generalizability and performance. And here where the our research is providing a solution to overcome this existence in LSTM challenges. And this enhancement is to apply the reflective item optimizer named as ReIDEM. So optimizer like ReIDEM when used in our research model, LSTM model, can potentially achieve faster coverage with a more stable and robust training dynamic and lead to better overall performance. And this will enhance the linear weight performance in the existing LSTM. Uh, as well, applying a sigma ReLU, which is a combination of two well-known activation function used in neural network, uh, such as ReLU and sigma. So sigma ReLU is a combination of two activation, ReLU and sigmoid, called as sigma ReLU. And this activation will help to prevent the Fisher gradient that occurred in the LSTM network and will make the LSTM more stabilized and doing stabilized learning during the backpropagation. And therefore, the enhancement continue to apply at dropout layers, and dropout will incorporate to into the architecture of the LSTM, and this will help to address the overfitting issues in the network. So the model architecture is showing the enhancement is being deployed into the existing LSTM by replacing the activation function used in the existing LSTM with the proposed activation function. And the LSTM structure is featuring a combined activation, such mentioned the sigma ReLU, which is a combine of sigma, sigmoid, and ReLU, and which stand in the formula of sigma ReLU alpha, where max 0 x is representing the real u, and plus the sigma x is representing the sigmoid, and this will tend to make the generalized learning rate in the training between 0 and 1. So that will make the performance of the model is smoothly during the during the learning patterns. And just from the figure below, from the standard long term, it can see that this existence LSTM, the standard one activation is typically sigmoid, or sometimes they use a time or ReLU, which is a limit input value between 0 and 1, but suffer from Fisher gradient and many existing challenge, but Sigma ReLU aims to build the strength of both Sigma and ReLU to overcome any challenges. The research data set is collected from the two different landfill, Lapis and Sagama, which is located in the south region of Malaysia. This consists of domestic swallow waste, a daily data set, ranging of over 3 years from 2020 till 2022. And the pre-processing of this data is being set to include the normalization for this data and handling the missing value by using some techniques to overcome this to handle the missing value and to clean the data set from any noisy patterns. And transformation data into sequence setable is necessary for LSTM layers. So the research, once the model is being deployed and ready to go, the data shows, the result shows a better performance and shows a highly protection model. And from this figure below, can see that the proposed model in this research has shown a good result compared to the existing and to others model that been compared to the proposed model. And from this figure here is Sagama ReLU. In the green, it shows the actual, and in the orange, it shows the, it shows the protection line, and can see the smooth tie line between the actual and projection data. Same goes for Lapis as well. And to evaluate this, to evaluate the proposed model protection, there being used some metrics to calculate the differences between the actual and projection, and to calculate the performance of model overall. And some of these metrics, they use the mean square error, mean absolute error, and the growth mean square, and the R square, and the variance square, and as well the accuracy. So overall, this table summarizes the LSTM performance, and it shows that the model is performing well, and the data, the differences between the predictive and actual data is show a lower value, which is highly good for this proposed model, and shows a nice performance with the accuracy of 93%. So to make this proposed model is good, there are being used some comparison. So the proposed model have been comprised with the standard LSTM and two different deep learning called as a gate recount unit, GRU model, and from the users comparing the LSTM with traditional LSTM and the GRU, is shown improvement in precision, accuracy, stabilize, and completion effective, and shows these the mean square error and mean absolute error for proposed model is being dropped down and is going to a lower value, which is highly good compared to the existence LSTM and to the GRU. And in terms of performance and accuracy, proposed model shows in highly result compared to the different deep learning that we used to compare to the model. And in this table, there are some comparison, a summary of a comparison model performance, and it can see and clear that the proposed model LSTM shows a better performance overall in general, and shows highly performance compared to the proposed model that being proposed to compare with the LSTM mentioned in this research. The proposed model is being modified to make a future prediction, and the LSTM model predict a future domestic soil waste generation using recent data to focus waste amount for special number of the next 30 days, or the next 3 months, 4 months, or for example, the next 1 year ahead. So the model process input data in a loop, reshaping it and storing the prediction in array or listed. So if the input length is 3 or less, meaning if I ask the model to train 3 days ahead to predict the next 4 day, so the model reshape the data generated a prediction and combine a looping until it reach the desired time frame. For example, here in this figure, we ask the model to predict the next 3 days, 13 days ahead, meaning the next month ahead. So from this figure below, it shows the future prediction made by the LSTM, and in terms of testing the model, it asks to generate a prediction for the next 4 months ahead for Sagama. And from the result, he shows the model can be good to make a prediction smoothly and to help to determine determine the next 4 months ahead. Overall, the LST model is developed to address some challenges and shortcomings issues in the traditional LSTM, demonstrated a remarkable propensity in prediction domestic soil origination by integration the sigma ReLU activation and the ReIDEM optimizer. It's overcome these issues and it surprised the capability of conventional neural network. So the precision and accuracy of by the LSTM shows a good result in forecasting waste generation profile available inside for optimizing waste management strategy in both landfill and a limited contribution to sanitary reports. And serving as a raw spot solution, the LSTM overcome this outperforms the standard of the LSTM. And in terms of accuracy and performance, presenting a transformation potential for forecasting cleaner and more stable waste management practice. For future work, this LSTM is being developed and improved into a user-friendly web-based system that utilizes the LSTM model to assess the management of waste system into management waste decision making. Thank you. That's all for me.
Thank you, Mr. Abdurrahman Sharaf, for the detailed and interesting presentation. So now I'm open for any questions to ask to Mr. Abdurrahman. For the audience, do you have any questions? We finally have one live presenter. Previously, we only have 2 live presenters. Do you have any questions? Okay, I guess no question from the floor, from the audience. Right, so thank you to all the presenters and participants for making this session informative. So we have explored a wide range of fascinating topics today, and I hope you all find the presentation as enlightening as I did. So this concludes our sessions for today. Please stay tuned for tomorrow. No. Sorry. Okay, I would like to ask the participants in the audience to turn on your camera, and we will have a group photo session. Please. Before we end our session, please turn on your camera so that we have the group photo. Okay, Mr. Rizwan already. How about others? Welcome. Okay, Mr. Deji Shen. How about Mr. Abdurrahman?
Yes, not okay.
Okay. Mr. Aliyu. Okay. How about others? Are you ready? We only have 4 person who turn on the camera. How about others? Come on. Okay, never mind. I just step with whoever we have now. Okay. Wait, yeah. Okay, once again, 1, 2, 3, smile. All right. That concludes our sessions for today. Please stay tuned for tomorrow's session as we continue with more insightful presentations. Have a great evening and see you all tomorrow. Thank you.
Thank you so much.
Okay, thank you. Bye-bye.
Bye-bye.
Bye.